In this video, we'll use the Passive Circuit DesignGuide to create a microstrip bandpass filter. Following that, we'll move to a layout view to define an EM setup for that filter and run a simulation in Momentum. The Passive Circuit DesignGuide can greatly speed up the process of creating common RLC, microstrip, and stripline passive circuits. You can easily create filters, couplers, and tees according to your specifications. We'll navigate to the Passive Circuit DG microstrip circuit palette and place a coupled line filter smart component. Note that we have several parameters that can be defined by the filter smart component, such as stopband frequencies, passband frequencies, attenuation at stopband and passband, and coupling type. These will all be taken into account by the design guide. Since we are creating a microstrip filter, we also need to place an M-sub definition. We'll change the thickness to 20 mils and the dielectric constant to 4. Select the filter, then go to Design Guide, Passive Circuit, and select Passive Circuit Control Window. Note that the current schematic and smart components are selected. The same Design Guide window can be used to change between schematics and smart components. Navigate to the Design Assistant tab and press Design. This will generate a design according to the parameters on the smart component. If we pop into the smart component, we can see the design that was generated by the design guide. Due to the limitations of the synthesis method used to generate your design, you may find that your circuits do not perform exactly as expected. You can easily optimize from the Optimization Assistant to more closely match your design with your specifications. A new optimized circuit is generated after you hit Optimize. Just like any design guide, the simulation of the smart component alone can be generated with standard 50 ohm terminations from the Simulation Assistant. Go to the Simulation Assistant tab, set the frequencies, and simulate. A number of plots with performance indicators appear in the data display. Most importantly, we can see the S21 data in dB plotted against our specifications from the filter smart component. We're now going to run our momentum simulation. Go to Layout, Generate Layout. We see a layout version of our filter has been generated. To create a mesh in S parameters, we need to add pins for testing. Select it from the toolbar and add it to the ends of your filter. We'll define a substrate for our EM simulation. In your EM setup, go to the substrate menu and create a new using the 25 mil Lumina template. We'll change our dielectric layer to FR4. Select the layer, then choose the material from the material definitions. We'll select the dielectric FR4 with a 20 mil thickness. Now move to the Frequency Plan tab and select a frequency range that is more appropriate to our bandpass filter. Since we had a center frequency at 2.1 GHz, we'll start at 0.1 GHz and sweep until 5 GHz. Now we'll finish by generating the S parameters for our filter. This will generate the substrate and the mesh, as well as run the S parameter simulations. Once we run our simulation, we can see the generated S parameter data. If we ran this simulation from the schematic using the Passive Design Guide, using the same frequency sweep, we would see the same response from the Design Guide simulation. Let's now move to the momentum simulation. Go back to the Layout view and navigate to the momentum simulation. To see an animation of the phase sweep, go to the Plot Properties tab and enable the Animate option. We can see the phase increment over different solution frequencies. Go to the Solution Setup tab and select a frequency inside the passband. At this pass frequency, we can see the coupling and signal transmission inside the filter. When we switch to a frequency just outside of the passband frequency, we can see how the majority of the current is contained near port 1, preventing transmission of the signal. Thank you for watching this Keysight ESOF EDA tutorial. You can find a link to a free trial of ADS in the video description below.